All right, good morning or good afternoon. Today we begin a new module, Module 1. This module is all about exponents and exponential notation, and then something that we're going to learn about called scientific notation. For today's lesson, we're just going to be kind of reviewing the basics of exponents before we get into some new learning this week about different exponent rules and laws when we work with it in math, okay? Let's go ahead and get started. All right, just to review some things before we get into our new learning today. 5 with a 6 in the corner is what we call 5 to the 6th power, okay? Our 5 is what we call our base. I'm just going to write some of these things off to the side here. The 5 is the base, and the 6 in this case is our power. Our base tells us what we multiply, and our power tells us how many times we multiply it. Okay? And so 5 to the 6th power, essentially it means 5 times itself 6 times. So 5 times 5 times 5 times 5 times 5 times 5. Okay? It is just a simpler way of writing that out because that would be a lot of writing as opposed to 5 with just the 6 in the corner is very little writing. Okay? If we look at 9 over 7 to the 4th power, well, there's a small minor difference here, and that is these parentheses. Essentially what that means is that we are raising everything within the parentheses to the 4th power. So our base here is 9 over 7, and our power here is 4. And so we're doing the whole fraction 9/7 times itself 4 times. If we did not have those parentheses there, that would mean that we were just doing 9 to the 4th power and then dividing that whole thing by 7. So our parentheses do matter when it comes to exponents. If there's anything you take from this lesson, it is that parentheses matter. Okay? They tell us what we are actually multiplying. So if everything in the parentheses is, grouped together, that means we're multiplying that entire group as our base. If nothing is multiplied, then that exponent just goes to that first number. All right? Let's go ahead and move on and get into some practice. All right, here we're going to do a little bit of practice. We're jumping right into exercises. I'm going to do a few with you, and then I want you to do the rest on your own real quick. So this first one, exercise 1, it says 4 times blank, blank, blank times 4. So it's saying 4 is being multiplied by itself 7 times. So what's being multiplied by itself? What's going to be our base? 4 is the number we're multiplying. How many times are we doing it? 7 times. Okay, that's how you would write that in exponential notation. Okay? If we look at, number 8, this whole number is grouped together, this whole fraction, negative 1 over 14, and we're doing that whole thing 10 times. So we're doing this entire number, we're keeping it in parentheses, this whole group 10 times. All right, so take a second, honestly take maybe 1 minute to go through, and please write out your answers in exponential notation here. There's a few where you're going to have to just tell me how many times it's being multiplied right here at the bottom. But go ahead and find your answers, please. All right, you should have had enough time to do that, or at least get most of them done. For exercise 2, we are doing 3.6. How many times? Well, it tells us right over here. We're doing it 47 times. Okay, so this number is 47. For exercise 3, we're doing negative 11.63, all grouped together, in parentheses, 34 times. So this is negative 11.63. You got to keep the parentheses, they matter. 34 times. Okay? Exercise 4, we're doing this 15 times. It tells us right here with our exponent. So we're putting a 15 here. Exercise 5, again, the parentheses matter. Negative 5 to the 10th power. All right, exercise 6 is where it gets a little bit trickier. So we have 7 over 2, and we're doing that 21 times. You'll notice that there's no parentheses here. However, if I just put 7 over 2 here and put a 21, this 21 would only go to my 7. But it's supposed to go to both the 7 and the 2 that's beneath it. So, although there's no parentheses here, I need to have them in my exponential notation because I need that 21 to go to both my 7 and my 2. Okay? Because that's what it shows me in this little depiction. All right? Exercise 7, it is negative 13 6 times. All right. Exercise 9 is just an x 185 times. So it's just going to be x 185 times. We can always use a variable within these expressions. And then we have x in to the nth power. So how many times are we doing this? We don't know. It's just represented with a variable in. Right? And this is just some review of how to write things in exponential notation. Again, just remembering that our biggest piece here that we're talking about is our parentheses. We want to know when we have to keep them. Okay, let's move on. All right, moving into a little bit of prediction work, we want to know if these products, if the answer to these questions is going to be positive or negative. Okay, so I want you to take a second to think about that and make a prediction here. We have negative 1, and we're doing it 12 times. So negative 1 times negative 1 times negative 1, 12 times. So what do you think? Is this going to be positive or negative? Well, to be honest, I think the easiest thing to do is to actually write it out. So we have negative 1. We're doing it 12 times. So there's 1, 2, 3, 4. I'm going to do a different color so I see it. 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I'm multiplying this 12 times. So now I'm just going to go through and I'm going to actually simplify this. Negative 1 times negative 1. This is positive 1. In fact, every little pair is going to be a positive 1. Okay, so I'm going to go through and just turn these a little bit simpler. Okay, so now I have 6 positive ones. And if I just keep doing that, now I'm going to do 1 times 1. Well, 1 times 1 is 1. And if I do 1 times 1 right here, and 1 times 1 right here, I'm going to get 1. And we know that our answer is just going to end up to be 1. And we already can see what our answer is going to be. Well, 1 times 1 times 1, it equals 1. And it is a positive 1. Okay. Now, what about the one below? Instead of having it done 12 times, it's done 1 extra time. So there's an extra negative 1 added to the end. I'll just show it right up here, adding a negative 1 right here. Okay. I'm going to erase my initial work so we can see that. So now that I have an odd number as my power, is this going to stay a positive? Well, just think, before we were able to pair all these numbers up and remove all of our negative signs. Now we can't pair them all up because it's an odd number. So this would be a negative 1 or a positive 1, positive 1, positive 1, positive 1, positive 1, positive 1, and then we have just a random negative 1 off to the side. So if we multiplied all these ones together, it's just going to equal positive 1, and then I have to multiply by this last negative 1, Negative 1 times positive 1. This gives me a negative. Okay? So we're going to come up with a rule right here. But essentially, if you have a negative that you're raising to a power, if the power is even, your answer will be positive. If the power is odd, your answer will be negative. Okay, we're going to practice this, so don't worry if you have not fully grasped it just yet. Let's go ahead and move on. All right, getting into a little bit more practice with this predictions about negatives and positives. We're going to do some practice here. It says, is it necessary to do all of the calculations to determine the sign of our product, of our answer? Why or why not? So we have negative 5 being raised to the 95th power. Do we need to actually write out negative 5 95 times to know if our answer is going to be positive or negative? No, we just need to look at our exponent. So this exponent is negative. No, look at your exponent or your power. 95 is odd. Sorry, I think I called it negative. I didn't mean to do that. 95 is odd. So our answer will be negative. Because we're going to pair up, the 94 together, and those will cancel out the negative sign, but that 95th one is not going to get a pair, and so our answer is going to have to be negative. Okay? The one below, negative 1.8, being raised to the 122nd power. Well, 122, that's an even number, so this is going to be positive. Our exponent is positive, or is even. So our answer will be positive. All right. So make sure you have that down. You can reference this throughout the lesson, and then obviously when you get to the Agnes ticket, you can reference this as well. We're going to get into a little bit more practice. Let's move on. All right, here I just want to check your learning. I want you to fill in the blanks. It says fill in the blanks indicating whether the number is going to be positive or negative. So is our answer going to be positive or negative based on what we see? It says if n is a positive even number, so if this power is even, what will it be? Positive or negative? Write in your answer. And the second one, if this is odd, what will it be? Positive or negative? Write in your answer. All right, you should have identified that if n, or if your exponent is even, it's going to be positive. If n is odd, it's going to be negative. Again, this is one of the rules we are learning today. One of the first rules we're going to be learning about exponents. Okay? There are so many rules we will learn, and it will be difficult to kind of keep track of them all. But I suggest, just making sure you reference your notes, you go back to things. The more we practice it, the more we write it, the more we see it, the more it will solidify in your brain. Okay? Let's continue on. All right, here we're going to do a check for understanding. Josie says that negative 15, that's in parentheses, 6 times is negative 15 to the 6th power. Is she correct? Message me in the chat. What do you think? Is she correct? I'm going to wait until a lot of people message me. Did she do this correctly? And then it says, how do you know? So really think about, how do you know if she's correct or not based on what you just told me in the chat. Well, I'm actually going to prove this with you. Okay, you don't have to write completely everything I write. I'll tell you what to write. But we have negative 15 being multiplied by itself 6 times. 1, 2, 3, 4, 5, 6. Okay? What she wrote was negative 15 to the 6th power. Now I'm going to tell you very quickly, and I want this to stick in your brain. if you put parentheses around this and you put it in your calculator, you're going to get a very different answer than if you don't put parentheses in this and you put it in your calculator. And here is why. If I were to multiply these out, we have an even number. So it's going to cancel out my negatives, right? 15 times 15 is 225. Okay. If I were then going to do 225 times 225, I'll get 50,625. And then I'm just multiplying that with my last 225. My final answer here is going to be very big. 11,390,625. Okay? Now, if you put this in your calculator, you're not going to get that same answer. And here is why. This in your calculator reads as a negative 1 times 15 to the 6th power. Okay? So instead of getting our positive answer, it's going to be the complete opposite direction on our number line, and it's going to end up being negative 11,390,625. Now, that doesn't seem like a big deal, right? Just a sign. Still have the same numbers. But that's, like I said, a completely different place on our number line. This is the difference between $11 million and being $11 million in debt, okay? So she is not correct. This is what I want you to write up here. She's not correct, and here's why. Parentheses matter. All right? Without parentheses, the exponent only goes to the 15, not the negative sign and the 15. Okay, and we need it to go to both of those things. All right? So again, this is what I want you to write here. Trying to prove it to you why this makes a difference. Okay? And again, it's the difference between a huge positive number and a huge negative number here that are very, very different. All right? Let's go ahead and move on to the next slide. All right, just to summarize our learning today, we can use exponential notation to write really large and really small numbers more efficiently. So like that last example we did, that was a very big number, but we had it just written like this. Oops, very small. We can predict if a number is written in exponential notation is going to be positive or negative depending on if its exponent is even or odd. If it's even, it's going to be positive. If it's an odd exponent, it's going to be negative. And this is only if we're doing a number that has a negative sign to begin with, okay? If we're doing just like 5 to the 6th power, this is already a positive number. It's going to be positive no matter what, okay? Lastly, parentheses matter when it comes to exponential notation. They tell us where to put our exponent, right? This means the exponent is going to the negative sign and the 15. This means the exponent is just going to the 15. Okay? Let's go ahead and look at what your exit ticket is going to be like today. Alright, here's what your exponent is going to look like today. Pretty simple, and it pretty much mimics what we did in our lesson. I want you to write this in exponential notation, just like our first examples. Okay? Then I want you to look at your work and tell me, is the answer to that question going to be positive or negative? Explain. Tell me how you know. All right. For number 2, I want you to tell me how many times this is being raised. Okay, so essentially filling in how many times it's being raised. This will tell you over here. And then the last one down here, it says Arnie wrote, negative 3.1 4 times is the same as negative 3.1 to the 4th power. Please tell me, is Arnie correct? Why or why not? Okay, so 3 questions, but it is 4 parts. All right. When you're finished with this, please do your reflection in Google Classroom.